This video is designed to show you how to use SPSS to conduct a factor analysis. For this example, we're going to use the SPSS anxiety scale that you were assigned to do for homework for this upcoming week. You can see, if we go to variable view, you can see each of the items entered into the label area, and then the values, how these items were rated by each individual, were based on a Likert scale ranging from 1 strongly agree to 5 strongly disagree. And then if they didn't answer the question, a 9 was put into the missing box. So then we'll go back to data view, and to start our analysis we'll go to Analyze, Dimension Reduction, and Factor. And you notice that all the variables are already in the factor box. I'm just going to reset this and show you how to move them over. You can move them all over at once. And then for the descriptives, if we pick the univariate descriptives, that'll give us the means and the standard deviations for each of the items, the correlation coefficients, the determinant, the KMO, and the Bartley's test of sphericity. And then we'll click on Continue. In terms of the extraction method, we're going to use principal components for this analysis. But we also want the scree plot available so it can help us evaluate how many factors to extract. And then we'll click on Continue. In terms of the rotation, for our purposes for this analysis, we're going to check Verimax. And then we want to make sure we have the rotated solution box checked, and then Continue. We're not going to use factor scores for this analysis, and so we're just going to skip to the options. And in this case, we want our coefficients sorted by size. That'll help us when interpreting which items load on which factors. And then we'll click on Continue, and then OK. So for the first part of the output, you can see that we have the means and the standard deviations for each item. And as we scroll down, this gives us our correlation coefficients, and so we can see how closely related each item is to one another, and we can see how unrelated those items are likewise. Then we go to the KMO and the Bartley's test, and the KMO with values greater than 0.5 tell us that we have good sampling, and that the matrix can be factored. The matrix of variables can be factored. And the Bartlett's test of sphericity, because it's significant, also suggests that the factor analysis meets the criteria necessary to proceed. We have our communalities, and for principal components communalities, they all start out with a 1. And then we have the extraction commonalities. These are the communalities that are produced as a result of the analysis. This tells us, this table tells us the amount of variance that's explained by the factors. And you can see that we have 1, 2, 3, 4 components or factors that were extracted. And we set our criteria that eigenvalues greater than 1, if you look here, would be considered and interpreted as a factor, and those below 1 would not be considered. So you can see we have these 4 factors, and they explain 50% of the variance in the data matrix. Our scree plot also helps us to confirm how many factors, and you can see right about here is where we see the upward part of the curve starting, and at that point that's where you look here on the x-axis and you can see that there's that this is at the 4 factor or the 4 component number, and it's somewhat difficult to interpret in this case, but between looking at the scree plot and looking at this table of total variance explained, we get a pretty good idea of how many factors we want to interpret. Then we come to the component matrix. This is the matrix and the factor and the loadings of each item on each of the components or factors. But this is the unrotated component matrix, so it's less interpretable than our rotated. And this is the matrix that we want to rotate. And we can see that the items in this factor all have high loadings compared to the others. So you see that I have little experience with computers, that factor loading is 0.800 as compared to the other ones, which are much lower. So we say that this item loads on this first factor. It's the same way with the other factors down to this point here. Computers are out to get me. And then we can switch over and we can see that now the next factor includes these that have the high factor loadings. And so you can see that these items clearly load together on the second factor. And then as we scroll down, we can see that then the next set of items here load on this factor. These 3 items, I have never been good at mathematics. I slip into a coma whenever I see an equation, and I did badly at mathematics. Those load together. And then finally you have the last 6 items loading together on the 4th factor. So now the goal is to say, or to look at the items and see how you might interpret what those items mean as one factor. So what you want to do is name this factor, factor 1, factor 2, factor 3, and factor 4 based on the items that they load on.